Hi guys, yes, I'm yawning. This is Unit 5, Lesson 11, Univariate Datasets, the unit test. So these are not the exact questions on the test. They are only similar. I use different graphs, different numbers, because I'm not going to cheat for you. I'd probably get them wrong anyway. This is only intended to help you know what steps to take to solve your own problems. And the reason I'm making this is because Angie's old math teacher used to do this and her new one doesn't. And I don't feel like it's fair that she had this tool to use for the entire year until now, and all of a sudden she doesn't. Warning, you will need to know the definitions for the following words. I cannot answer this question for you. Be prepared. If you don't know what these terms mean, you need to stop the video right now. Go find the definitions for these and be prepared for this question. Screwing up this one question will cost you major points on the exam. It's going to drop your grade a lot. It's going to really hurt you because each one of these is worth a point. So this one question is worth 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. So you have the potential to get 10 questions wrong. If you get one of these wrong, you're guaranteed to get a second one wrong. So you're going to go down by 2 points every single time. Take the time to make sure you know what these mean before we move on. Okay, here's an example of what number one is going to look like. They're going to give you a dot plot and they're going to say what is the range of the data sets shown. This is not the dot plot that you're going to have. This is just a random one that I pulled. How you find the range is you find your top value, which is 7. There are no values on 8. Look how big that is. Let's fix that. We're not going to use 8 as the top of our range because there were no dots on 8. Our top number is 7, and we're going to subtract our lowest value, which is 0, which means our range is 7. That is how you find the range. Your answer will probably not be 7. If it is, I would seriously consider you did something wrong. Here's number 2. How many total people participated in this survey? Again, this is not your chart, okay? How you figure this is with a frequency table like this, okay? You're going to count up how many here, and add them all together. So here's 2. Here's another one. So 3, 4, 5, 6, 7, 8. 8 plus 8, because it goes up here to this line. 8 plus 8 is 16, plus another 6 is 16, plus 6, I'm trying not to screw this up because, you know, I'm a moron, is 12, another one, 22. So for this chart, the total number of people is 22. For your chart, it's going to be a different number, but that's how you figure out how many people participated or how many whatever, okay? Number 3, given the data set blah, what parts of the 5-number summary would change if a new data point was added? So we're going to find 2 different 5-number summaries, okay? First, we have to look at this and see if it's in order. It's not. Stupid, 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 stupid. So first, we have to put it in ascending order. It looks like 58 is going to be our lowest number, so we're going to go 58. These are not your numbers. I changed them. 58, no 60s, so 70, 2 75s, 75, 75, okay, chunk, chunk, 78, 79, 78, 79. Go slow and take your time on this, because if you get this out of order or miss a number, your whole answer is going to be wrong, guaranteed. 83. It's tedious and stupid, I know, but it matters. 85, 87, chink chink, 85, 87, 88, and 89. Well, let's make sure I got every number. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, we need a 5-number summary for this set. Our minimum is going to be 58. Our maximum is going to be 89. Now we need to find our median. We had 10 numbers, so halfway is 5. 1, 2, 3, 4, 5. Because it's an even numbered set, We need both of them. So we need the middle two. So we're going to take, got my calculator, 79 plus 83, and then we're going to divide that by 2, and there's our median. It's 81, okay? So our median is 81. Okay, now our dividing line is going to be right there, chunk. We need to find the median for the first half. 1, 2, 3, 4, 5. It's going to be the third number. Chink, 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 chink. It's going to be 75. Okay. Median for the second half is going to be chink, 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 chink. 87. So there's our first 5-number summary. Okay. Now we're going to redo this, but we're adding another 87. Okay. So let's erase my marks and hopefully not anything else. Well, look at that. I did. Okay, so what number came after 78? I don't remember because I'm a genius. I'm a genius. Watch me go. After 78 was 79, it looks like. Okay, so this is going to be 79. And we need an extra 87 in here. So I'm going to erase here. We need another 88 and 89. So we've got 87, 88, and 89. Okay, we're going to have the same maximum and minimum. We still have 58 and 89. Let's figure out what our median is. We have 11 points now, so we need 5.5. 1, 2, 3, 4, 5.5, which means that this is going to be our median, 83. Okay, now we need to find our new quartile 1 and quartile 3. So this one gets left out. Okay, we're dealing with only these numbers. 1, 2, 3, 4, 5. It's going to be 75. Okay, and 1, 2, 3, 4, 5. 87. So there's only one number that changed here. We still have 58, 75, but 81 became 83. Okay, so what parts of the 5-number summary would change if a new data point was added? The median and the median only. Okay, chonk, 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 chonk. That's for this problem. Your problem may be different. Okay, maximum, Q1, median, Q3, minimum, maximum. Okay, here is number 4. What is the median of the data? So how you figure this, you need to count how many dots you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We have 17. We need to find the halfway point. 17 divided by 2 is 8.5. 1, 2, 3, 4, 5, 6, 7, 8.5. Chalk. Our median is 32. Okay? Again, your answers are going to be different. Here's number 5. Hortensia made the dot plot to help her plan for her quinceañera. Find the mean and median number of seats per table, mean and median, to show that the mean and median are different in this skewed data set. Round your answer to the nearest whole number if necessary. So you can see this is skewed. Here's the dinosaur's head. Here's its tail. Okay, so let's find the mean and median. Now, if this were a symmetrical one, they would be the same number, but it's not. So let's start with the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, we have 15 people. Okay, well, 15 tables. I don't know. I'm not sure. 15 dots. We'll go with that. I don't want to think that hard. Okay, so half of that is going to be 7.5. 1, 2, 3, 4, 5, 6, 7.5. That is our median. Okay, median is equal to 3. Okay, let's find the mean. Mean requires math. So we're going to go ahead and pull up our calculator. We need to add each of these and then divide by the total number of values, which is 15. I'm going to skip these zeros because 0 plus 0 is 0. We're going to start with the 2. So we have 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 4 plus 5 plus 6 plus 6 plus 6 plus 7 gives us 48. Divided by 15, which is how many dots we had, means 3.2 is our mean. Okay, 3.2 is our mean. Okay, so they are in fact different numbers because this data set is skewed. Okay, Now it wants us to round to the nearest whole number. Now if we do that, in this case, this mean ends up being just 3, and they're not different numbers for this one, but that's because I used a different graph. Yours will be different numbers. I just grabbed a graph, okay? Here's number 6. The median is the best measure of center for which data set? Okay, so this one is almost symmetrical, this one is skewed, and this one is skewed, okay? So which is going to be the best measure of center? When we're dealing with like a symmetrical or an almost symmetrical one, the mean and median are going to be the same, okay? So symmetric, I mean, it could be, but that's not what it's trying to get at, okay? When you're dealing with trying to figure out the best measure of center, the largest range, the flattest doesn't matter. I mean, how many data points you have going up and down is completely irrelevant to determining the measure of center, okay? So the best measure of center is the median works best with skewed data, okay? So this is going to be your correct answer, because when you have outliers, like especially on this one is going to screw with the mean, because it's going to pull the mean that way falsely. This is an outlier. This one does not show what most of the information is showing. Does that make sense? Okay. So this is not the full answers that they provide you, but these are the different things that they're saying based on the graphs. They're saying, it's the best because it's skewed, or it's the best because it's flattest, or, letter C is best because it's symmetric, or it's best because it has the largest range. Your answer is going to be skewed, because when you have outliers, they mess with the mean, okay? They make it falsely pull further to one side than it should be. Obviously, the center of balance is going to be over in this area on this one, right? But this one, if you do the math, is going to make it slide that way. Skewed is going to be your best answer for this one. You'll have to look and make sure. This one, both mean and median are going to be right here. This one, you got the dinosaur's head and tail. It's the median is going to be somewhere over here, and the mean's going to be pulled that way a little bit, but these aren't as much outliers as this one is. This one's very obviously like, number of home runs per player. This guy is like a superhero. This guy's not human to get this many home runs. This one is more, this is normal, but there's 5 players that can do good things, right? This one's very obviously not normal, okay? That's what you're looking for, is what's not normal. Here's number 7. So it just gives you this A graph, not this graph, A graph, and it says, it wants you to it doesn't even ask a question. It just gives you answers and wants you to determine which answer, okay? So let's look at this and say the mean is greater than the median. Well, this is symmetrical, and the mean and median are going to be the same in a symmetrical graph. The mean is less than the median. Nope, they're going to be the same because it's symmetrical. So it has to be that one. In a symmetrical graph, the mean and the median are always the same, okay? Use the mean to find the balancing point of the given data set. When you have a U-shaped graph like this, you don't have a center, you have a balancing point, okay? And that's the balancing point. If we put this on a little stick, we could balance it exactly right there, right? It would stay there. But if I put the stick like over here, it's going to go dunk and fall off, okay? So we need to find the mean to find what the balancing point is, okay? Obviously the balancing point's right there, but we're going to use the mean to figure it out. So what we need to do is grab our calculator and move scoochy, 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 okay? And we're going to do 38 8 times. So I'm just going to go 38, 1, 2, 3, 4, 5, 6, 7, 8, okay? 46 times. 1, 2, 3, 4, 5, 6. 42 4 times. 1, 2, 3, 4. 44 twice. 1, 2, 46 4 times. 1, 2, 3, 4, 5, 6. 48 6 times. 1, 2, 3, 4, 5. Oops. 6. And 58 times. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that gives us 1,764. Now I need to figure out how many I need to divide it by. So 8 and 8 is 16, plus another 6 is 24, plus 4 is 28, plus 2 is 30, plus 4 is 34, plus 6 is 40. Okay, so divide by 40 gives us 44.1. Okay, so the mean for this one would be 44.1. Okay, which makes sense. Looking right here, the balancing point would be 44. Okay. Here's number 9. Calculate the average deviation from the mean for the following data set. Whoops, round your answer to the nearest hundredth. Okay. Average deviation means we don't have to do the complicated math. We just get to start with non-negative numbers. Okay. So first we need to find what the mean is. So we're going to take these numbers, which are already in order. Thank you, book. And we're going to, these are not your numbers. Remember this. Okay, I'm going to have to just move the calculator because you can't see it. We have 23 plus 24 plus 26 plus 27 plus 28 plus 30 plus 31 divided by 1, 2, 3, 4, 5, 6, 7. Divided by 7. Our mean is 27. Okay. So now we need to find our average deviation. So we have 23 chunk 24 chunk 26 chunk 27 chunk 28 chunk 30 chunk 31. Okay, we need to figure out how far each of these points is from the mean, which is 27. So the difference between 27 and 23 is 4. 27 and 24 is 3, 1, 0, 1, 3, 4. Now we're going to take all these and add them together. Dinky 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 dink. 4 plus 3 plus 1 plus 1 plus 3 plus 4 gives us 16 divided by 1, 2, 3, 4, 5, 6, 7. 16 divided by 7 is going to give us 2.2857. They want us to round to the nearest hundredth, so it's 2.29. 2.29 is my final answer, not yours. Here's number 10. Which graph has the larger standard deviation? Okay, when you see standard, they want the complicated math. Average, we get to do it the easy way. Standard, we have to do it the hard way. So first we need to find the mean. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 data points here. Let's grab my calculator. I don't think I can fit it on there. Sorry, I was going to try to show you. We have 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 3 plus 4 plus 4 plus 5 is 30 divided by 10 is 3. So our mean for this one is 3. Let's go ahead and make our little chart. We have 1 chink, 2 chink, 3. Oh wait, I can do this. 2 chink, 3 chink, 3 chink, 3 chink, 3 chink, 4 chink, 4 chink, 5. Okay, there's all of our data points, and first we need to go 1 minus 3 is negative 2. 2 minus 3 is negative 1. Negative 1. 0, 0, 0, 0. 4 minus 3 is 1, 1. 5 minus 3 is 2. Now we need to get rid of the negatives, so we're going to square all these numbers. 4, 1, 1, 0, 0, 0, 0, 1, 1, 4. Okay, now we need to add all these together. So 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 divided by n minus 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 minus 1 is 9, so let's do 12 divided by 9, which I know I should be able to do, but I don't do math. 1.333333, okay? So this one is 1.33, we'll say. Oh wait, I need to take the square root of that. I keep forgetting. Square root of that gives us 1.15. Okay. 1.15. Okay, there's our final answer for that one. Let's erase all this garbage. And we're going to do the same thing over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's also 10 data points over here. Let's figure out the mean. First, we're going to add all of them together. 2 plus 2 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 4 plus 4 gives us 30. Divided by 10 gives us 3. Our mean for this one is also 3. So we have 2 chonk, 2 chonk, 3. 3. Whoops, that was low. 3. And that's what was that one? 3. 3. 4. 4. Okay, 2 minus 3 gives us negative 1, negative 1, 0, 0, 0, 0, 0, 0. 1, 1. We're going to square these to get rid of our negatives. 1, 1, blah. 1, 1. Add them together. We have 4 divided by n minus 1, which is 9. So 4 divided by 9 gives us 0.444444. Square root of that gives us 0.66666. So this one is 0.67. It didn't tell us how far to go, so I'm just going to the hundredths. There are our final answers, and it wants to know which has the larger standard deviation. In my case, it would be this one, okay? Because the number's bigger. Let's see, number 11, Addie's bus pickup time is 8 o'clock. The table shows the minutes before and after 8 o'clock the bus arrived at the stop for the last 10 days. Negative values represent the minutes before 8 o'clock. Calculate the standard deviation, so we got to do the harder math, for the number of minutes the bus arrived before or after 8 o'clock. Round your answer to the nearest tenth. Okay, so the first thing we need to do... this is your frequency. This is how often. This was the minutes late that the bus came. Okay, so the first thing we need to do is figure out the mean. So let's grab my calculator. And we're going to go -1 plus a -1, which is going to be minus another -1, plus 0, which is going to do nothing, plus 2, which is going to take us to 0, plus 3 plus 3. Okay, so our mean is going to be 6 divided by 1, 2, 3, 4, 5, 6. 6 divided by 6, so our mean is 1. Okay, let's go ahead and make our little chart and fill it in. We have -1, -1, 0, 2, 3, 3. And this is based on the frequency, so I didn't put 1 because there were no days that it was 1 minute late. Okay, we need to square these, so we have +1, +1, 0, 4. Oh, wait. We're not squaring these yet. We are finding the deviation first. Watch me close. Watch me close. So a -1 minus 1 is -2. -2. 0 minus 1 is -1. 2 minus 1 is 1. 3 minus 1 is 2. 2. Now we get to square these. So now we have, and I'm out of room, so I'm coming over here, I guess. 4, 4, 1, 1, 4, 4. Let's add all these together. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're going to have 18 divided by n minus 1. 1, 2, 3, 4, 5, 6. So 5. Let's grab my calculator. 18 divided by 5 gives us 3.6, and we need the square root of that. So it's rounded to the nearest tenth, so it's 1.89. Our final answer is going to be 1.9. My final answer. Yours will be different. Here's number 12. Which data set has the least variability? Okay. Gives us data set number, mean, and standard deviation. This is all irrelevant. They always give this, and I don't know why it's here. All you have to do is look here for the smallest number, which in my case happens to be this one. Okay. Least variability, smallest number. Here's number 13. Use the standard deviation to compare the variability of the data sets. Standard deviation is hard math. Round to the nearest hundredths. Which data set has the larger standard deviation? Which has more variability? Let's find our mean for this data set. Data set A. 3 plus 4 plus 5 plus 11 plus 12 gives us 35 divided by 1, 2, 3, 4, 5 gives us 7. So the mean for this one is 7. Let's make our little chart. We have 3, 4, 5, 11, 12. 3 minus 7 is going to give us negative 4. 4 minus 7 will give us negative 3. 5 minus 7 will give us negative 2. 11 minus 7 will give us 4. 12 minus 7 will give us 5. Wow, let's square them all. 16, 9, 4, 16, 25. I'm busting out my calculator for this. We're going to add these together. 16 plus 9 plus 4 plus 16 plus 25 gives us 70. We're going to divide that by n minus 1. So 1, 2, 3, 4, 5. 70 divided by 4 gives us 17.5. We need the square root of that, which is, and we want it rounded to the hundredth. So it's 4.183. So this one is going to be 4.18. Okay, let's find the standard deviation for our next set. Yay! Are we so excited? Okay, let's find our mean. 5 plus 6 plus 8 plus 10 plus 11 gives me 40. Divided by 5 gives me a mean of 8. Okay, make our chart. 5, shink, 6, shink, 8, shink, 10, shink, 11. 5 minus 8 is negative 3. 6 minus 8 is negative 2. 0, positive 2, 3. Let's square these. We have 9, 4, 0, 4, 9. I don't want to try, so I'm going to get the calculator. 9 plus 4 plus 0 plus 4 plus 9 gives us 26. Divided by 1, 2, 3, 4, 5. So 4. 26 divided by 4 gives us 6.5. Square root 2.549. So this one is 2.55. Okay. So now we go back to our question. Which data set has the larger standard deviation? That would be data set A. It has the larger number. Okay. Which has more variability? That would also be data set A because it has the larger number. Here's number 14. Calculate the values for the 5-number summary of the skewed data set. Thank heaven it's in order. 5-number summary. Minimum is 4. Maximum is 15. Let's find the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So median is 6.5. 1, 2, 3, 4, 5, 6.5. There's our beautiful median right there. 7. Let's figure out our Q1, quartile 1. 1, 2, 3, 4, 5. Quartile 1 is going to be 5. And quartile 3 is going to be 8. That's it. We're done. Okay. That's how you solve yours. Those are my numbers, not your numbers. Here's number 15. The consistency of a drink machine is being tested. The machine dispenses the following ounces of waters in 5 different trials. What is the IQR of the dispensing trials? All right, I need my notes. Where are my notes? Because IQR, you should have this in your notes. The formula for IQR is equal, that looks like a 12, sorry, is equal to Q3 minus Q1. So first we need to create a 5-number summary. Does that look a little more R-ish? Okay. Ah, look, they're not in order. So we have 11, 12, 12, 13, 15. Okay. 5-number summary. 11 minimum, 15 maximum, 12 median, 12 Q1, 13 Q2, Q3, sorry. Q3 is 13, Q1 is 12, IQR is 1 for me. You need to solve it out for you. Here's number 16. Again, no question. They just give you a graph and they want you to choose which one is correct. Okay. So our first option is sales before 8 p.m. always had a lower number of sales. Well, this is before 8 p.m. That's obviously not true because that it would have to like stop here before after 8 p.m. started. So that one's out. Most sales involved 40 or fewer customers. Well, here's 40, so that's saying that most sales happened over here. Well, for the nacho stand profits, for the 8 before 8 it did, but not for everybody. So that one's out. Purchases after 8 p.m., which is this blue one, were more likely to involve more customers. Yeah, because 75% of the sales were 50 or above. So that one works. The mean number of sales after 8 p.m., okay, was higher than 70. Okay, this is skewed, so the mean is not going to match exactly with the median. But in a skewed data set, it's going to go shrunk like that, because most of the data is over here, which means the mean's going to get pulled that way of the median. So is the mean going to be above 70? No. So that has to be my answer. Number 17, I can't answer this one because I could not find anything even remotely close to this. But this is the exact problem. Okay, you have these two graphs and it wants to know which of these could possibly be the correct answer. I'm going to give you a hint. Okay, they're trying to trick you on this one. If you look at this graph and this graph, let me bring them to the front. Layer. I'm sorry. Bring to front. Layer. Bring to front. Okay. There's something between these two graphs that is very different. Okay. And you need to find what that is. They're both skewed right. Okay. So that's not it. But there's something here that you need to pick up on in order to answer this question. And it's obvious once you see it, but you need to stop and look at these graphs. It's right there. It's right in front of your eyes in order to answer this question. Okay? So figure out what's different between these two. It's not the shape of the graph. Okay? And then you can go and find what your correct answer is. You need to slow down on this one. Okay? And really look at these graphs and figure out what's different between them before you try and go answer it. Okay, this is the other one that I can't answer for you. This is the vocabulary one that I told you to stop at the beginning and go figure out. And I don't know why this is here. You don't need that. Okay, but go figure this out. Okay, I hope you did because I'm not going to give you any help on this one. Here's number 19. A student wants to find the mean of the following data set. Okay. The steps used to find the mean are shown below, but they are out of order. I can't tell you this, but I can show you how I would find the mean. So I look here, and the first thing I notice is that these are out of order, so I need to put them in the correct order. The next thing I would do, mean is the math, okay? So I would add all of these together and then divide by the number of units or whatever you want to call it that I have here. So I would add them all together and then divide by 1, 2, 3, 4, 5, 6, 7, 8. And that's going to give me my mean. Okay. Here's number 20. A student wants to find the median of the following data set. Here's our data set. And then it wants the steps in order. Again, I can't tell you this, but I will tell you how I would solve it. First, I look at it. It's not in order, so I need to put it in order. Then I'm going to count how many there are. 1, 2, 3, 4, 5, 6, 7. Divide that by 2, which gives me 3.5. And I'd go 1, 2, 3.5, and whatever number is here in my new order is going to be my median. Best of luck to you guys. After all, you're using me as your math teacher.